Hey guys, welcome back to the linear relationships topic. Today we're going to be looking at the direct variations part of the topic. So we've already looked at the linear relationships part, the linear modeling part, and now we're going to look at the direct variation part. There's going to be two parts on direct variation. This is the first part. So if we look through our syllabus points here, we can see that the first one is to recognize that a direct variation relationship of the form y equals kx produces a straight line graph. So whenever you see anything like y equals kx, that means that's what we're talking about when we mean direct variation. It means when a variable y is directly proportional to a variable x and is altered by a factor of k. Okay, so y is equal to x multiplied by a factor of k. So the k could be greater than 1, less than 1, positive, negative. It doesn't matter. It's just showing how y behaves with respect to x due to that factor of k. The next thing is to explain that a direct variation relationship of that form is a graph that passes through the origin with gradient k being the constant of variation. So if you have any direct variation graph that looks like this, k can be any number at all, negative, positive, of any magnitude, and you will always get a linear line that passes through the origin. So something like this, if k equals 1, you might get y equals 1x, which would look something like that. Now this relates back to our basic form of a linear line, y equals mx plus b, where our m coefficient was our gradient. In this case, k is just replacing m. We're talking about k as our gradient rather than m, but it really means the same thing. And for any direct variation, they all pass through the origin because there is no constant term b on the end. And if you recall from my linear modeling video, the constant b on the end always represented our y-intercept. But since we're not adding or subtracting any constant on the end, therefore our y-intercept is 0 because it's the same as having y equals kx plus 0. So 0 is our y-intercept, which is clearly going to be at the origin. So that's a bit of an explanation as to why that is. But of course, if you're not sure, you can always sub in values for y and x and check that way too. And finally, our third dot point is to identify and represent direct variations from descriptions of situations in which one quantity varies directly with another quantity. So that's what I was talking about earlier when I said y varies directly with another quantity. So y will vary with x, and k will tell you the factor about how much y will differ compared to x. Okay, so that's a theory. Now we'll do a couple of examples. So the first one here is just to sketch y equals 3x. So this is a direct variation question. It's nothing complicated at all. So of course y equals 3x is just going to be a straight line going through the origin at a relatively steep angle, and it's got a positive slope, so it's going to be going up and to the right. So that is y equals 3x. If your slope is positive, it's going up to the right. If your slope is negative, it's going up to the left. And then when you look at the magnitude of your slope, that will determine the steepness of the slope. So say we have, if we wanted to sketch y equals negative 5x, just to compare it with this one. So two things are different about it. One, it's going to be steeper because the magnitude of that k value is 5 compared to 3. So it's going to be steeper for one. And two, it's going to be going up to the left instead of up to the right. So if that is y equals 3x, y equals negative 5x is going to look something like that. It is going to be steeper and is going to be going up to the left. But what they do have in common is that they're both passing through the origin because they both have no constant term being added to it. Or if you want, you can think about it as they have the same constant term being added to them, which is 0. Doesn't make any difference at all. So we can see that y varies directly with another variable x, and it changes based on this factor 3 or negative 5, whatever it may be. So if we take y equals 3x, what that means is that for every x value that increases by, the y value will increase by 3 times that amount. That's basically what it's saying. So we get our little triangle forming up here. So for every one increase in x value, your y value will increase by 3 times. That's essentially what this is saying. Okay, let's move on to the next example. So if we've got some practical situations here, so it says So we've got basically worded situations, and we've got to put them into, so identify and represent direct variation from the form y equals kx from descriptions in which one quantity varies directly with another quantity. That's the third dot point there. So that's what we're doing. We're putting the words into the equation here. So if we look at the first one, it says the distance d, a car travels over t hours if it is traveling at a constant speed of 25 kilometers an hour. Okay, so our two variables we're trying to relate here are d and t. And now all we've got to do is relate them and use what we know to relate them. So d will change with respect to t, and it will change by how much? It will change by our gradient, which in this case is 25. So d will be equal to 25. This means that for every t value that increases, for every time t increases by 1 unit, which in this specific example is 1 hour, you are traveling another 25 kilometers. So if you travel for 1 hour, you've traveled 25 kilometers. If you've traveled for 2 hours, you've traveled 50 kilometers. So d will always be 25 times larger than the amount of hours that you've been traveling. And that will give you a distance in kilometers. The next example, the money earned, represented by y, by an employee who gets paid $30 an hour and works t hours. So now we're relating the values y and x, all right? And we've got to, again, work out what our gradient or what our constant is to directly relate them. And of course, that is 30 in this case. So y is always equal to whatever x is times 30 times larger. Oh, sorry, that shouldn't be an x, that should be a t. So y will always be 30 times greater than whatever t is. So no matter how many hours this employee works, he will get paid 30 times the amount of hours he works. That's the amount of dollars that he earns, or the money that he earns that goes into his pocket. So I hope these questions make sense, and I'm going to do another direct variation video covering this in more detail with a few extra syllabus dot points as well that I haven't covered in this video. Thank you.